equations. So just throwing a lot of information out at you these first couple slides. Keep in mind slope-intercept form is y equals mx plus b. We can be utilizing point slope form. Y minus y1 equals m times x minus x1. Slope formula will need to come into play at some point. Vertical lines and horizontal lines, we have to remember from the graphs that a vertical line has an undefined slope. An equation for that is just x equals some number. Horizontal line, your slope is 0. Your equation is y equals some number. A little bit more to recall. Parallel lines never touch, so they have the same slope. Perpendicular lines cross at a 90-degree angle, so their slope happens to be the opposite reciprocal. Examples of opposite reciprocal: if I give you a slope of positive, let's go 2/3, 2/3. Opposite means opposite sign. Reciprocal means flip the fraction. So this would be your normal slope. That would be your perpendicular slope. All right, another example here is if I gave you a slope of -2, perpendicular slope would be the opposite sign, so the positive, and then reciprocal is flip the fraction, so it'd be 1/2. Those are some examples. Now let's actually get into some real examples. We're going to write the equation of the line using the given information. All answers need to be in slope-intercept form, no matter what form you use to get us started. I'm going to kind of build our way through these problems. The first two here, the easiest ones. You have what you need. To write an equation of a line, you need the slope and y-intercept. So we go through, we have both here. We have y equals 1/2 for your slope, x, and then -5 for your y-intercept. That's it, you're done. M and B is the easiest thing. You're given your M here. If you know this is your y-intercept, this is quick. Remember, y-intercepts are 0 and then some number. So in this case, just like the last problem, it's y equals -2x plus 6, and you're done. M and B is what you need. Now, you're not always going to be given that information. So we move forward. This one we have M, our slope in some point, some random point on the line. It's nothing special about it. So I'm going to show you two ways to go about this. So we have M, we have X and Y. We can go ahead and plug this into slope-intercept form in order to figure this out. So we have 2 for our slope, X is 7 plus B. Go through, solve for B. -3 equals 14 plus B, subtract 14. B is -17. You have your slope, you've had your slope, you now have your y-intercept. We piece it all together, and we have our equation of a line. We have a second example, but I'm going to show you how to use point and slope form. So we're going to use point and slope form. So we're going to call this x1 and y1. I actually like point slope form a lot. I think it's the easiest one to use, in my opinion. It is the harder of the two to remember, and I think that's what keeps a lot of people from using it. So we have our M, our x1, y1, so we just go ahead and plug it in. So we go y minus 3 equals 4/5 times x minus 5. You distribute the 4/5. First part's easy. 4/5 times x is just 4/5 x. 4/5 times -5, it just happens to be -4. We add 3 to it after that. And we have our equation. No need to plug anything back in. That's why I personally like slope-intercept form. So we have that. Next, we're going to jump into special cases really quick. We'll just call this 5A and B. We're going to use the same or similar information, different slopes, same points. So we have to remember, if the slope is 0, that's a horizontal line. Horizontal lines have equations y equals some number. With that said, if you're worried about the y, that means all you're worried about is the y from this point. So your equation of this line is y equals -5. That's it. Just the opposite here with vertical lines. This is vertical. Vertical lines have an equation of x equals some number. So if all you're worried about is the x, you're just worried about the x here. So it's just x equals 7. And that's the equation. Moving on, we have writing equations from 2 points. I'm only going to go through 1 in the video, but I'll show 2 in the notes. So we have to find our slope first. So our slope formula was this: difference in the y's over the difference in the x's. So it doesn't matter which one's x1, y1, x2, y2. That's up to you. I'm going to call this x1, y1, x2, y2. So that'd be 0 minus -3. That turns into a +3. Then I'm going to go 4 minus 3. 3 over 1 is just 3. And that's my slope. So I have a slope. I have 2 points to choose from. And it's exactly that. You need to choose. It doesn't matter to me what you pick. You just need to pick one. I personally am going to pick the one with 0 in there. All right, it makes it easier to work with in the long run. I told you guys I prefer to go ahead and use point slope. So I'm going to go y minus y1. This is now your y1 or whatever you want to call it. It's y minus 0. Makes it easy there. Your slope is 3. We have x minus 4. That's gone. All you have to do is distribute and you're done. Our equation of the line is 3x minus 12. And that's all we have.